How's it going, everyone? In this video, I want to talk about the fact that I think computer programming, at least at a high level, is more of an art than a science. Now, I know it's a little controversial for me to say that, right? When most people think about computing, when most people think about writing code and software engineering, they think of it as a science, right? We study computer science in school. It's like one of the most popular degrees that you can get. So it is this very scientific thing. But I want to make the argument that at a high level, specifically at the level that most people are coding at nowadays, it is more of an art than a science. At the very low levels, computing is about science. In fact, it's mostly just based in logic. When you think about what a computer is, it's just a set of logical circuits that all come together to create this intelligent system. But nowadays, computer programming, I really do think it's more of an art than a science. And let's take this as an example. There are a million different ways that you can write the same code. So let's say, whatever you're trying to do, right? Let's say you're trying to build a to-do list app, or maybe you're trying to, add two numbers together. Well, maybe not add two numbers together. Let's say you're trying to, perform some complex calculation or write some piece of code. If you ask 10 developers to write that same code, they'll probably all write it a little bit different. They'll write it 10 different ways. If you ask 10 developers to build a to-do list app, they'll build it 10 different ways. And it's because there's so many different ways that we can kind of do the same thing with code. Coding at a very low level, it's just a set of tools. It's a set of instructional tools that we can use to tell a computer how to do something. But there's so many of these different instructions. There's so many different ways that we can tell the computer to do the same thing that when it comes down to it, it's really about the individual developer and how they want to write it. Now, most of the time, let's say you're working for a company, you'll have a code base, and that code base is going to have a coding standard or a coding style, right? There'll be a set of best practices that have been established in the code base, and then all the developers will kind of follow that. So they'll sort of write things the same way. But really, when we're working at that level, when we're working at the level where you can do the same thing in all these different ways, it stops becoming a science. It stops becoming about this is the provable best way to do something, and it starts to become more about intuition. And that's really, I think, if you're at a level where you're writing code and, maybe you're just kind of starting out, I wouldn't say that it's as much of an art at that point, right? You need to learn the syntax. You need to learn how to sort of speak and write in this language. But once you really master a computer programming language, once you master these core fundamentals, I do think it becomes about art. It becomes about the developer looking at a problem, a developer looking at a system and saying, what's the best way for me to write code in this system? And it really depends on where you're writing it. If you're writing code in one language, it's going to look different than if you're writing code in another language. If you're writing code for the web, it's going to look different than if you're writing code for maybe a mobile app or something like that. So as much as we want to say that this is a science, at a high level, it is just about making decisions. It's about designing systems. I mean, really, if you want to talk about the difference between good and bad software, and I've talked about this in another Rant video, but it almost never comes down to the individual lines of code in some algorithm. It almost never comes down to one function or one thing that's written really, really well. It's a symphony of functions. It's a symphony of conditionals and logic and if statements and variables and data, and it all needs to come together in this very orchestrated way. And this is not something that's scientific. Being able to take, getting this data from the user and then manipulating it in this way, and we have this algorithm over here, and then we send it over to this system, and then we send it over to that system. It's an orchestra. You're literally orchestrating this entire intelligent being, essentially, right? As programmers, we're creating intelligence. This is not something that is provable or scientific. I had, when I was in grad school, I had some classes, just on very low level logic and things like that. And one of the things that we did is we tried to prove a program's correctness. So that was one of the exercises. We kind of learned how you could prove that a computer program would do what it's supposed to do. And while it technically works, this is not the way that computer programmers are writing code. We're not writing a system and then sort of writing a proof that proves it does what it does. This is a dynamic, living, breathing system, and we have tests to sort of keep it in line, and we have bug fixes, and we have these, all these different patterns and ways that we develop things like Agile or whatever. So really it's like how much of what you're doing as a computer programmer every day, and I guess I'll pose this to whoever's watching this, like how much of it is scientific versus how much of it is just you looking at the code that's already there and saying, okay, how does my code fit into here? Or, you looking at this code base and saying, okay, I need to get data from this file and we have this piece of state and then we have this user interface element. I need to combine all of these together, and you're using best practices and you're doing all of those things. Like if you want to seriously up your game as a developer, one of the things that is worth looking into is design patterns. I had a whole class on design patterns. These things are awesome. But design patterns are ways of sort of best practices for organizing code. This is not a scientific thing, right? If you're architecting a system as a senior developer or something like that, you are just as much an artist as anyone, I think, who's painting or drawing or, doing something that's traditionally considered creative. Being able to take all these disparate parts of a system and, like I said, sort of symphony them together and orchestrate this whole process of, the application running and you're handling all these different error states. This is something that it's not scientific. This isn't provable. This isn't something that you can just go learn how to do in a book. You have to just go in and have that intuition for how it all fits together. And I think the more that we see computer science, and I'm saying computer science, the more that we see programming as a science, I think the further away we get from being good programmers. I think to be a good programmer, you have to be creative. To be a good programmer, you have to be able to think intuitively and think on your feet and be able to be creative, right? Even if we're talking about writing technical algorithms or anything like that, I would say one of the most creative parts, I think, of computer programming is recursion. To me, recursion is the coolest thing about computer programming. It's a function that calls itself, and designing a recursive function, it's such a mental exercise, and it's not at all scientific. It is very creative. You have to be able to think abstractly. You have to be able to think in all these different ways. So look, as a beginner, if you're a beginner and you're watching this, it might not be as applicable. This is one of the problems with computer programming, is that there's just this huge learning curve, right? If you know nothing about coding and you want to get to the point where you're designing and architecting these big systems, it's going to be a couple years probably before you're able to do that. So there is this big learning curve. You have to learn how to think, and you have to learn how to design and do all these things in a different language, in a different paradigm, right? You have to learn how to think differently to do that. So there is this big learning curve, but I feel once you get over that threshold, to me, coding is it's just art. It's so artistic. It's so creative. And I think in a lot of ways, it's so expressive as well. You have the instructions to build intelligence. You're creating intelligence. So I guess this is my message to people who are beginners, or I guess also to people who are senior dev level, right, higher level at coding. What if we started to see it more as a creative endeavor? What if we started to see it more as an art than a science? Because I think that's the correct scope to look at it in. Look, if you're designing, a logical circuits, or if you're designing the hardware for a processor, yeah, it's scientific. You should know your science. You should be an engineer. But at these high abstract levels where we're building and architecting and orchestrating apps, I think it's better to look at it as an art than a science. So if you're just coming in and if you're somebody who's creative out there and you're an artist, or you are just in that space and you're not very technical, or you're not an engineer or whatever, computer programming might be for you. Look, there's a big learning curve, of course, but when you get to the other side, I really do think it can be just this amazingly expressive endeavor. And if you're a senior dev and you're seeing yourself as the very technical person, and this is science, and this is, we're doing science. It's try looking at it as art. Try looking at it as design and as something that's creative, and you're taming and you're building and you're basically curating this intelligent system. I don't know, computer programming is just so cool. It's just such a cool thing. We're able to build intelligence. We're able to literally create something out of nothing, something out of logic. This is so cool. Are we too narrow-minded with what this is? Are we so focused on making money, or are we so focused on building the same app over and over and over again that we're stifling our creativity? What if a developer said, you know what, instead of building another to-do list app, or instead of building another note-taking app that's already been built 800 times, what if we step out of our comfort zone a little bit, we get creative, and we build something that's like really, really unique and cool and interesting, and something that's a piece of art? Why can't you walk into an art gallery and there's, a really beautiful piece of code just there, right? I don't know, like why isn't that art? So I think it is art. But I think we need to change our perspective on some of this stuff. So, okay, that's the message of this rant. Maybe we can look at ourselves more as people who are creative. And look, not everyone's, fitting into this mold, but I think we need to look at programming as more of a creative endeavor. Because at the high levels, at the levels where you're designing systems and you're building applications and you're writing tests, writing tests, you need to get so creative. But it is a creative endeavor. I really do think it's more of an art than a science. It's more of an intuition. It's more of an orchestration. It's more of a symphony than anything else. So yeah, I guess that's all I have to say on that. If you like this video, please leave a like. If you agree with me, if you disagree with me, let's leave a comment. We can start, maybe we can get a little bit of a conversation going. But yeah, at the end of the day, I think maybe we need to all get more in touch with our creative sides when it comes to writing computer code. So thank you for watching, and I'll see you in the next video.